Hi guys, welcome to lesson 2 in week 2. You can see today that we are going to be looking at volumes of composite shapes. So our composite shapes are just shapes that are made up of two or more shapes that we know how to calculate the volume of. So for example, here we can see that we've got two shapes. Hopefully we can spot that shape number 1 down the bottom is a cuboid, and that shape number 2 at the top is a cylinder. It's up to you what way around you do these. I've labelled number 1 my cuboid, so I'm just going to start with that. So my volume of shape number 1 then is going to be length times breadth times height. So the length of my cuboid is 8, my breadth of my cuboid is 4, and the height of my cuboid is 7. But again, remember, because we are just multiplying these three numbers together, it doesn't really matter what way round we are writing them down in. So if you've done 7 times 8 times 4, you will still get the same answer and you won't lose any marks. If we fire that into our calculator, we should get 224, and again, volume is centimetres cubed. For volume number 2, our cylinder is pi r squared times by the height. So my r is my radius of 3, but my issue this time is that my height of my cylinder is only this bit here, and we have been given the full height of the shape, which is 20. But we already know that 7 centimetres is made up of the cube, so if I do my 20 take away 7, I get 13. So 13 centimetres is the height of my cuboid. I am going to plug that into my formula, so pi times by 3 squared times by 13. 3 squared is 9, and then if I just pop that into my calculator, I should get 367.57 centimetres cubed. What we now need to do is find the total volume. So these two shapes have just been combined together. So our total volume is going to be V1 plus V2. We are adding them together. So that's 224 plus 367.57. So our answer here is 591.57 centimetres cubed. For example 2, we can see here that we've got a kind of ice cream looking shape. So shape number 1 is our hemisphere and shape number 2 is our cone. We know that our volume of a sphere is 4/3 pi r cubed. Now our issue here is that if it is a hemisphere, we're going to have to divide that full thing by 2 at the end. Now our problem here is that we need our radius, and we have been given the diameter again. So we need to know that our radius, wiggly line there, is 5 centimetres. So we're going to have 4/3 times by pi times by 5 cubed, and then we'll divide that by 2 at the end. That's then 4/3 of pi times by 125, and then dividing by 2. What I want to do then is my 4 times by pi times by 125 first of all, and that is going to give me 1570.8. But I'm still going to divide that by 3, and then we're halving the full thing to get our sphere. So I'm going to divide that number by 3, and then divide that answer by 2, and I end up with 261.8 as my answer. For volume, we always need to add in our units, so I'm going to have centimetres cubed. For the second volume then, it is a volume of a cone, so I've got 1/3 pi r squared h. Now we know that the radius is going to match up because the circle of our cube matches the base of our hemisphere there. So we know that it's going to be 1/3 of pi times by 5 squared, but the height of the cone isn't 15. The 15 includes this bit of our hemisphere. But if that is going from the centre of the hemisphere up to the edge of our hemisphere, then we know that that's the radius. So that bit there is also 5 centimetres. If I take 5 off, I'm going to get 10 centimetres. So the height of my cone is 10 centimetres. I'm going to do a third of pi times by 25 times by 10. So really that is going to be my pi times by 25 times by 10. And we are going to divide that by 3 because we still have our third to do. So really my answer here, the 785.4 comes from that pi times 25 times 10. I still need to divide it by 3, and so I get 261.8 centimetres cubed. So there our volumes actually match. We've ended up with the same volume for the cone and the hemisphere. Our total volume then, so our total volume is just going to be our 261.8 plus 261.8, and that is going to give us 523.6 centimetres cubed. You'll be glad to know that this is your final example for today's lesson. We are going to find the volume of the cuboid when the cylinder has been removed. So we've still got two shapes here. We've got shape 1 is our cuboid and shape 2 is the cylinder. So I'm going to start with the volume of my cuboid, which is length times breadth times height. So for my cuboid, that's going to be 15 times by 10 times by 5. And that gives me 750 centimetres cubed. My second volume then was my volume of a cylinder, which was pi r squared h. So for this example, we have been given 7 as our diameter of the cylinder. So my radius is going to be half of that. So the radius is just 3.5 centimetres. That means then we're doing pi times by 3.5 squared times by the same height. So that cylinder fits perfectly inside our cuboid. So it's still times by 5 for the height. And our answer then should be 192.4 centimetres cubed. This time the cylinder has been removed, though it's not added onto the cuboid, it's been taken out. So here our total volume then is going to be the volume of our cuboid subtracting the volume of our cylinder. So we're doing 750, take away 192.4, and that gives us 557.6 centimetres cubed for our answer. Here are your questions. There are 8 of them to attempt today. If you find that you are really confident with your volumes and that you flew through these questions but you ran out of time with the previous lesson that you had, feel free to finish these questions and then go back and get extra practice at the ones from yesterday. Otherwise, these are the 8 questions I want you to attempt today. Again, you are allowed to use a calculator for all of these questions, but I still want to see all of your lines of working. Show me as much as you can when you're doing your work. And remember, we are now uploading our work at the end of each week to our class notebook on the general channel in our team. Good luck with these questions, guys. Contact me if there's any issues and I can go through questions individually, and I will see you in your next lesson.